Hello, welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for physics for the year 2013. This is the first part of the recording. We are going to look at the first 25 questions for this year. Before we continue, don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scalars.com to practice the UTME exam and modular quizzes for free. Alright, first question here is on paper type. Which question paper type of physics is given to you? So in this recording, we are using the paper type D. Okay. Now this question is very essential. It determines how your exam is going to be marked. Okay. Picking the wrong paper type means that your answers are going to be marked against answers that are meant for another paper type. Okay, and that can greatly affect your results. So endeavor to check out for the paper type that you've been given and pick from whatever you have. I mean, if you have a question like this, pick the paper type that corresponds to what. Second question: when a brick is taken from the Earth's surface to the moon, its mass. So the mass of a body is constant. Okay, the mass of a body, unlike its weight, is constant. It does not vary with location, unless that body has lost some of its particles. Okay, that is when the mass may reduce, and if it gains particles, it will increase. But if that did not happen, without that, okay, mass of a body is constant, even during phase change, like when a body changes from solid to liquid to gas and all of that, mass is still constant, but the weight varies with position, okay, with location. Next question: the resultant of two forces is 50 Newton. If the forces are perpendicular to each other and one of them makes an angle of 30 degrees with the resultant, find its magnitude. That is the magnitude of that force that makes an angle of 30 degrees with the resultant. Alright, so we're going to draw a diagram here, and this is the diagram here representing those two forces. So you have these forces F1 and F2 that are perpendicular to each other. What that means is that the angle of inclination between them is 90 degrees. Okay, so this here is going to represent the resultant force. Alright, it will represent the resultant force. Now we have that one of those forces make an angle of 30 degrees with the resultant force. Let's say that it is this force F here, and the angle between this force F and this resultant force is 30 degrees. This is not to scale. Okay, so let's assume that the angle here is 30 degrees. So what we want to calculate is this force F here. So how do we get the value of this force F here? Is by resolving this horizontal force in the horizontal. We resolve it in the horizontal. To resolve it in the horizontal with the angle of inclination to the horizontal, we are going to use cos. So our force, the horizontal component of this force here, okay, that is this F, is going to be equal to the resultant force cos theta. Okay, cos theta, the angle between that this force here, okay, I mean the angle between the resultant force and the horizontal force and the horizontal. So you have the resultant force from the question to be 50 Newton. You have 50 cos 30. Cos 30 degrees is 0.8660. So you have 50 times 0.8660, and this is 43.3 Newton. Next question: the pair of physical quantities that are scalar only are. So physical quantities are classified as scalars or vectors. Okay, scalar quantities are those quantities that require magnitude only. Alright, they require magnitude only. While vector quantities are those quantities that require magnitude and direction for their specification. Okay, now from this list here, we have to identify the pair of physical quantities that are scalar only, and from this list, that will be volume and area. Okay, momentum is a vector quantity, displacement is a vector quantity, impulse is a vector quantity. So it is only this pair that consists of scalars only. So volume and area, they are scalar quantities. Next question on motion: a simple pendulum of length 0.4 meter has a period of 2 seconds. What is the period a similar pendulum of length 0.8 meter? What is the period of a similar pendulum of length 0.8 meter at the same place? Alright, so what we look at first is what is the relationship between period and length. Okay, the period and length. Okay, now the period of a pendulum bulb varies directly as the square root of the length. Okay, it varies directly as the square root of the length. Now remember in Charles' law, for example, I just want to draw something here in terms of variation. Okay, a fast one here. We have in Charles' law, V is directly proportional to T. Then we say from there we get V1 over T1 is equal to V2 over T2. We are going to do a similar thing to here. T here is directly proportional to root L. So this will then, if you turn this to an equation, it will become T1 over root L1 is equal to T2 over root L2, where this T1 will mean the initial period, okay, and the initial length, while this T2 here is going to mean the new period, and this L2 is going to mean the new length. So the initial value is there, okay, the original period, the initial period is 2 seconds with a length of 0.4 meter. So you have T1 as 2 seconds, L1 as 0.4 meter. Alright, so you are now to find the new period. That is, what is the period? That will be the T2 if the length is now 0.8 meter. So you just substitute this into the equation there. So you have 2 over root 0.4 is equal to T2 over root 0.8. Now what we are going to do here is to remove this root that is here. We are going to square both sides. So if we square this side of the equation, we are going to have 2 raised to power 2, that will be 4, and root 4 raised to power 2. If we do root 4 square, okay, the square is going to remove the root, so we are going to be left with 0.4. This will now be equal to T2 square over, if we square this root 0.8 as well, the square will remove the root, so we have 0.8. So here 4 divided by 0.4 is 10. This will then be equal to the period raised to power 2 over 0.8. We can cross multiply this 0.8 here. If you cross multiply this 0.8, we are going to have 10 times the 0.8, and that will be 8 is equal to T2 square. To get the value of T2, the new period, we are going to take the square root of both sides. So T2 is going to be equal to the square root of 8. Alright, how do you find the square root of 8? Root 8, we are going to write it as root 4 times root 2. Root 8 is equal to root 4 times root 2. Now root 4 is 2. Okay, so root 4 times root 2 will become 2 times root 2, and that will become 2. That will be 2 root 2. So the new period with this length of 0.8 meter is going to be 2 root 2. Next question on motion. A train with an initial velocity of 20 meters per second is subjected to a uniform deceleration of 2 meters per second square. The time required to bring the train to a complete halt is, okay, the initial velocity of the train here is 20 meters per second. The initial velocity, that is u. The acceleration, okay, is minus 2 meters per second. Why is it minus? Because this is deceleration. Okay, deceleration is a case of negative acceleration. Alright, so the final velocity, they said this train, okay, was brought to a complete halt. Now when it came to halt, its new velocity or its final velocity is going to be 0 meter per second. So the new velocity v is going to be 0 meter per second. So the question is to calculate the time t that it will take to bring that train to a halt. So to do that, we look at, okay, which of the equations of motion can we use, okay, with these values that are given here. So we are using this equation here, which is the first equation of motion. V is equal to u plus at. In this equation here, we have the final velocity, the initial velocity, the acceleration, and we are looking for the time here. So we solve for all of these values here. So v is 0, the final velocity, initial velocity is 20, plus, now acceleration is minus, so plus times minus, this will be minus 2t. Alright, then I can bring this minus 2t to this side. When it comes to this, it will become plus, that is, I will have is 0 plus 2t, and that will be 2t is equal to 20. To get the value of t, I will then divide both sides by 2. So if I divide both sides by 2, t will be equal to 10 seconds. So it will take 10 seconds to bring that train to a complete halt. Next, calculate the apparent weight loss of a man weighing 70 kg in an elevator moving downward with an acceleration of 1.5 meter per second square. We have the acceleration due to gravity as 10 meter per second square. Alright, now as the man is moving down, okay, the weight that the man is going to feel is going to be less than his actual weight. There's going to be a loss in the weight of the man. Now the weight of the man, okay, originally is 70, the mass of the man is what we are given here as 70 kilogram. Okay, 70 kilogram. Okay, so the actual weight of the man is going to be the mass of the man times the acceleration due to gravity. That will be 70 times 10, which is equal to 700 Newton. This is the actual weight of the man. Now we will look for what is the weight of that man in that lift. What's the weight of the man in the lift? Now since the lift is moving upward, Okay, then the tension in the cord, okay, the tension in the cord is given as, sorry, since the weight is moving downward, the tension in the cord C is equal to mg, which is the weight of the man, okay, minus the force with which the weight is with which the body is moving down. Okay, so you have mg minus ma, or m in bracket g minus a, where this is the acceleration due to gravity and a is the acceleration of the lift in which, or the elevator in which the man is. So the weight of the man from the question is 70. Okay, so we have 70 in bracket. Acceleration due to gravity is 10 minus acceleration of the lift, which is 1.5. So you have 70 times 10 minus this is going to give us 8.5. So you have 70 times 8.5, that is 595 newton. So this is the weight that is felt in the lift. The weight loss of the man is now going to be the actual weight of the man minus the tension in the cord of the elevator, okay, or the weight that is exerted on the floor of the elevator. So that will be 700, this 700 here minus 595, so that gives 105 newton. Next question: a piece of cork floats in a liquid. What fraction of its volume will be immersed in the liquid? We have the density of the cork as 0.5 times 10 raised to power 3 kilograms per meter cube, and the density of the liquid as 1.25 times 10 raised to power 3. Okay, if we have a body, okay, let's say a body A floating in a fluid B, for example, then the fraction of its volume that will be immersed is going to be the density of that body over the density of the fluid in which it is floating. So the volume, okay, of this cork that will be immersed, okay, that will go down in that liquid, is going to be the density of the cork over the density of the liquid. So that will be 0.25 times 10 raised to power 3 over 1.25 times 10 raised to power 3. 10 raised to power 3 will cancel 10 raised to power 3, so we are going to have 0.25 divided by 1.25, and that will be equal to 0.2. Next question: an object is moving with a velocity of 5 meters per second. At what height must a similar body be situated to have a potential energy equal in value with the kinetic energy of the moving body? Alright, the kinetic energy of the body is given as half. Next, on work energy and power: if a pump is capable of lifting 500 kg of water through a vertical height of 60 meters in 15 minutes, the power of the pump is, okay, power is equal to work done, okay, over time, work done over time. So the power of the pump is going to be the work done in raising the body through that height or distance over the time, okay, and that work done is going to be equal to the weight of the body times the height to which the body was lifted. The weight of the body is given as mg, mass of the body times acceleration due to gravity. Okay, so we have mgh over t. From the question, the mass is 500 5,000 kilogram, the height here is 60 meter, the time, okay, is 15 minutes. We will need to convert this to seconds. As you can see that the units that we have here, they are in joules per second, and we have this time here in minutes, so you have to convert to seconds so that the unit can be balanced. Okay, so to convert from minutes to second, we multiply by 60, so here you have 15 times 60, and that is 900 seconds. Okay, so we then substitute for these values here. So the mass times the value of our acceleration due to gravity, which is 10, times height, which is 60, divided by the time, which is 900 seconds, and this will give us 3,333.333. If you write this in standard form, since this is 3,000 and something, we can write it as 3.3 times 1,000, which is 10 raised to power 3. We have our website at scalars.com, where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scalars.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. freebies are also available to top performance on the website. The coefficient of friction between two perfectly smooth surfaces is. Alright, the formula for coefficient of friction is given as the frictional force over the normal reaction. Now, if the surface is perfectly smooth, okay, then we say that the frictional force is negligible. Alright, it means that the frictional force between the two surfaces is negligible, so we take it as is 0. So the coefficient of friction is going to become is 0 over the normal reaction, and the 0 divided by anything would give you is 0 besides the 0 itself. Okay, 0 divided by any non. What effort will a machine of efficiency 90% apply to lift a load of 180 Newton if its effort arm is twice as long as its arm? Alright, so we have mechanical advantage is equal to load over effort. Okay, the mechanical advantage of a machine is equal to the load over effort. Now in this question they gave us the load. Okay, we have a load of 180 Newton. We are given the load. However, we are not given the value of the mechanical advantage, so we cannot use this formula directly to get our effort. We need to first look for the mechanical advantage, and to do that we are going to use the formula for efficiency. The efficiency of the machine is equal to the mechanical advantage of the machine over its velocity ratio times 100%. Now let's look at the other things that were given in the question. The efficiency of the machine is given as 90%. Okay, so you have 90%. Now they didn't give us the velocity ratio. Okay, so how did we come to conclude that it is 2? Is that the velocity ratio is the distance moved by the effort divided by the distance moved by the load. Okay, the distance moved by the effort divided by the distance moved by the load. Now in the question they said the effort arm is twice as long as its load arm. That means that if the load arm is, let's say, 2 for example, the effort arm is twice as long, meaning the effort arm is going to be 2 times 2, it will be 4. If the load arm is 5, the effort arm is going to be, if the length of the load arm is 5, then that of the effort arm is going to be what? 10. Okay, if this is 10, this one will be 20. So anyway, if you now take the distance, okay, or the length of the effort arm over the length of the load arm, you will be getting 2. Okay, so we say our velocity ratio here is 2 because it will take 2 times the distance that it will take to move up the load arm, to move up the effort arm. So we then substitute that into this formula for efficiency. Efficiency, which is 90, is equal to mechanical advantage over 2, the velocity ratio, times 100%. 2 here 1 and 2 here is 50. 50 times MA is 50 MA. Okay, so you have 90 is equal to 50 MA. To get the value of our mechanical advantage, you then divide both sides by 50. If you divide both sides by 50, the mechanical advantage is going to be equal to 1.8. Okay, then we'll go back to using this formula here. That mechanical advantage is equal to load over effort, or you can say that the load over effort is equal to mechanical advantage. So you say the load over effort is equal to the value that we got here for mechanical advantage, which is 1.8. So we have the load 180 over the effort E is equal to 1.8. Then we cross multiply this effort here. Okay, the effort here is the denominator here, why this is the numerator here. So we will cross multiply, and we are going to have 180 is equal to 1.8 E. To get the value of the effort, we then divide both sides by 1.8, and here we are getting 100 Newton. So we have the effort, okay, that will be applied by the user to be 100 Newton. Calculate the work done when a force of 20 Newton stretches a spring by 50 millimeter. The work done in stretching the spring is given as half Fe, where F is the applied force and A is the extension produced in that spring. So the force in the question is 20 Newton. We are given the extension in millimeter. Okay, 50 millimeter. So we convert this to meter by dividing by 1000. Okay, to convert from millimeter to meter, we divide by 1000. So 50 divided by 1000, that would be 0.05 meter. So we then substitute in this formula here. So you have half times 20 times 0.05. 2 here 1 and 2 here is 10. So you have 1 times 10 times 0.5, and that will be 0.5. Next question: at what depth below the sea level would one experience a change of pressure equal to 1 atm? We have the density of the seawater to be 101, 10,013, and 1 atmosphere is given as 1.01 times 10 raised to the power 5 Newton per meter square. Acceleration due to gravity is 10 meter per second square approximately. Alright, so we want to know at what depth, okay, are we going to experience a change of pressure equal to 1 atmosphere. The formula for pressure in a liquid is given as H rho G, that is the height times the density times G. Okay, so you want to know at what height H is the value of what we have here going to be equal to 1 atmosphere. So that is, we just equate this thing here to 1 atmosphere, then substitute for the other values that we have, and then find our H here. So that 1 atmosphere is 1.01 times 10 raised to the power 5. That will be equal to the height H times the density, which is 1013, times gravity, acceleration due to gravity is 10. Okay, now 10 raised to the power 5 means 10 times 10 in 5 places. Okay, so 10 raised to the power 5 is going to be 100,000. Alright, 100,000 times this will give us 101,000. This will then be equal to, here we have 1013 times 10, so this will be 10,013, 10,130. So 10,000, to get the value of our H here, we will divide both sides here by 10,113, and that will be equal to 9.9 meter. Approximately, this is 10 meter. Next, what volume of alcohol? We have the same mass as 4.2 meter cube of petrol. We have the density of alcohol as 8.4 times 10 raised to the power 2 kilograms per meter cube, and the density of petrol as 7.2 times 10 raised to the power 2 kilogram per meter cube. Alright, we want to know, okay, that equal mass, or if you have an equal mass of or what volume of alcohol is going to have a mass that is equal to 4.2 meter cube, this volume of petrol. Now density, the formula for density is mass over volume. If you want to make the mass the subject of the formula here, we are going to multiply this volume. So the mass will now be the density multiplied by the volume. Okay, so since the mass of them, like of both of them, is equal, or you want to know, like from the question is what will be the volume for their mass to be equal. So to begin with, let us equate their mass. That, let's say the mass of the petrol is equal to the mass of the alcohol. Now here we said mass is equal to density times volume. So mass of the petrol will mean the density of the petrol times the volume of the petrol equal to the mass of the alcohol, which will be the density of the alcohol times the volume of the alcohol. So in the question, they already give us the density of the petrol as this, alright, times the volume of the petrol, which is 4.2 meter cube. We then say this is equal to the density of the alcohol, that's 8.4 times 10 raised to the power 2, times the volume of the alcohol. Alright, so here 7.2 times this 4.3 is going to give us 30.96, then times 10 raised to the power 2. This is equal to, this times VA will be 8.4 times 10 raised to the power 2 VA, where VA is the volume of the alcohol. To get the value of VA, we will now divide both sides of this equation by what you have here. Okay, by 8.4 times 10 raised to the power 2. So if you divide both sides by 8.4 times 10 raised to the power 2, how are we going to do this? 10 raised to the power 2 is going to cancel 10 raised to the power 2. That is out. Then we are going to have 30.96 divided by 8.4, and that will give us 3.69 meter cube. So 3.69 meter cube of the alcohol is going to have the same mass as 4.2 meter cube of the petrol. Next, calculate the length which corresponds to a temperature of 20 degrees Celsius if the ice and steam points of an ungraduated thermometer are 400 meters apart. So for a question like this, we are going to do interpolation. Okay, that is, we are going to relate the intervals, okay, on this thermometer and the standard thermometer. Okay, so in the standard thermometer, the ice point, the upper fixed point, is 100 degrees Celsius, the lower is 0 degree Celsius. Okay, so the difference between them, the upper fixed point and the lower fixed point, the difference between them is 100 minus 0. Okay, so that means they are 100 degrees apart. Okay, now for this thermometer, the distance is 400 millimeter. Okay, like it's 400 millimeter apart. Let's say like the upper fixed point is 400 and the lower is 0. That may not necessarily be the case. Okay, maybe the upper fixed point is, I wouldn't know, 450 and the lower one is 50, for example. But the difference between it basically is 400. Okay, so that is what we have there. Now, if 100 degrees Celsius, okay, is 400, we are assuming that, let's say, the lower fixed point of the standard thermometer is 0 degrees Celsius, and that is it, 0 degrees Celsius. And for this thermometer, let's assume that it's also 0 degrees Celsius, and the upper fixed point for the for the standard thermometer is 100. For this one, it is 400. Okay, so we say that 100 degrees Celsius corresponds to 400 millimeter. Okay, so we can say that 1 degree Celsius is going to be equal to 400 divided by 100. That will be 4 millimeter. Okay, it means that 1 degree Celsius on the standard scale is equal to 4 millimeter on this scale here. Okay, so if we now have a temperature of 20 degrees Celsius, then that is going to become 20 times 4 millimeter for this thermometer here, and that will be 80 millimeter. Okay, I think this is a simpler, faster way than even interpolation, and it sure is faster. Next, a wire of length 100.0 meter at 30 degrees Celsius has linear expansivity of 2 times 10 raised to the power minus 5 per Kelvin. Calculate the length of the wire at a temperature of minus 10 degrees Celsius. So we see that there has been the wire here has reduced. The temperature rather of the wire has reduced, and the wire here is solid. Generally, when the temperature of a solid reduces, okay, when it drops, all right, the solid would contract, meaning it's going to become smaller. Okay, solid expand when they are heated, when their temperature rises, and when their temperature falls, they become smaller. Okay, they become smaller. So we can expect that the new length of this wire, the original length is 100 meter. The new length, we can expect it to be less than this 100 meter. So these options we are having 100.08 and 100.04. Greater than this cannot even be the answer. Alright, so we are left with these two here. Okay, so let's now do some calculation here. Now, the original length of the wire is 100 meter. Okay, the change in the temperature is going to be the new temperature, which is minus 10 degrees Celsius, minus the old temperature, which is 30 degrees Celsius. So you have minus 40 degrees Celsius here. Now, the next thing we are going to do is this. We want to calculate the change in the length of the wire. Actually, in the question, what they want us to find is the new length of the wire at this temperature. But we need to know what is the change in the length. For example, this is the original length of the wire, 100 meter. Okay, let's now say that I know that after heating the wire, the change in length of the wire is 10, for example. That means that the new length of the wire is going to be what? 100 plus 10. It should now become 110. And let's say that if the length reduces, let's say the change is, that means the change is going to be negative. Okay, the change is going to be negative. So let's say it changed by minus 10, meaning the length dropped by minus 10. That means that the new length is now going to be 100 minus 10. Okay, and that will be 90. So the point is that we need to know what is the change in the length in order for us to get the new length. So we then use this formula here. Change in length is equal to alpha, which is the linear expansivity of the material, times the original length times the change in temperature. The linear expansivity is given as 2 times 10 raised to the power minus 5 per Kelvin. So we multiply this by the length, the original length, which is 100 meter, then times the change in temperature, which is minus 40 degrees Celsius. Now, 10 points minus 5 means 1 over 10 raised to the power 5. Because this is a negative power here, it means 1 over 10 raised to the power 5. So if I now have 2 times 1 over 10 raised to the power 5, that will become 2 over 10 raised to the power 5. And 10 raised to the power 5 means 10 in 5 places. 10 times 10 times 10 times 10 times 10, which is 100,000. So 2 over 10 raised to the power 5 is going to be 2 over 100,000, which will then give me here this is 0.00002. So we multiply this by the original length 100 by the change in temperature minus 40. By the time we multiply all of this, we'll be getting minus 0.08. Now you can see that this is negative. What that means is that the length reduced instead of increased, and you can understand why here, because there is a reduction in the temperature from 30 degrees Celsius to 10 degrees Celsius. It means that the temperature even fall below. It even fell below, zero. It even fell below zero since it is negative. So that's why I'm having a negative value here. So we say the change in length is equal to the new length minus the original length. Okay, if we now bring this original length to this side, we are going to have the new length to be equal to the original length minus this change in temperature, in length rather. So the original length is 100, so we have 100 minus 0.08, and this will be 99.92 meter. Next question: a gas at a pressure of 10 raised to the power 5 Newton per meter expands from a 0.6 meter cube to 1.2 meter cube at constant temperature. The work done is, okay, the work done here is going to be equal to the pressure, okay, the pressure of the gas times the change in the volume of the gas. So here the gas expanded from 1.2 meter cube to a 0.6 meter cube. So the change in the volume is 1.2 minus 0.6. So you have 0.6 meter cube. The work done will then be equal to the pressure, which is 10 raised to the power 5, okay, multiplied by 0.6, the change in the volume. So you have 0.6 times 10 raised to the power 5. Now I'm going to borrow 110 from here and use it to multiply this 0.6. So if I borrow 110 from here, this will become 10 raised to the power 4. I'll now say 0.6 multiplied by that 10, and that is going to give me 6 times 10 raised to the power 4. That's a simpler way to understand this. Okay, or you can decide to, okay, why this is 0.6 in standard form. So that's going to be 6 times 10 raised to the power minus 1, then multiplied by 10 raised to the power 5. You can now use the law of indices on 10 raised to the power minus 1 and 10 raised to the power 5. We say 10 raised to the power minus 1 times 10 raised to the power 5 is equal to 10 raised to the power minus 1 plus 5, and minus 1 plus 5 is 4. Next question: two liquids X and Y having the same mass are supplied with the same quantity of heat. If the temperature rise in X is twice that of Y, the ratio of specific heat capacity of X to that of Y is. Alright, now the ratio of the change in temperature, okay, the ratio of the rise or the change in temperature of the substance is going to be the inverse for the ratio of their specific heat capacity. Now what I'm saying is the temperature rise in X is twice that of Y. It means that the ratio of change in temperature in X to change in temperature in Y is going to be 2:1. Okay, since X is twice of Y, so X ratio Y for the change in temperature is going to be 2:1. Now for that specific capacity, you just invert it. Okay, you just switch it, so it's going to be 1:2. I want to leave it at this. Okay, this is a very simple way to explain this. All right, that, or let's say that the specific capacity varies inversely as a change in temperature. Okay, so if the change in temperature of this one is double that of this one, then the specific capacity of this is going to be double that of this. I hope this is clear. If this one is double this in terms of change in temperature, then this one will be double of this one in terms of the specific heat capacity. So that's the simple way to put it. Just switch it. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scalars.com, or you could also check it out in the video description below. Foods cook quicker in salt water than in pure water because of the effect of I don't know, there are many tongue twisters in JAMB question. Food cook quicker. Food cooks. Can you say that like 10 times? Food cook quicker. Food cook quicker. Food cook. I'm not sure I can do that. Okay. All right. So let's the question. Sorry. Foods. Okay. Cook quicker in salt water than in pure water because of the effect of dissolved substances on the boiling point. Okay. These dissolved substances are impurities, and impurities, what they do is they help to lower boiling point. Okay, they help to, impurities, they increase they lower melting point and they increase boiling point. All right, now salt insignificantly increases the boiling point while it lowers the specific heat, and therefore food in salt water is going to cook faster. Okay, it will lower the specific heat of the water. Now you will think that, okay, but the salt in the water is an impurity, so it's supposed to increase, the boiling point. So the food is supposed to take time before it will cook. Okay, but there are two things that is happening here. The salt is increasing the boiling point while it is lowering the specific heat. What this means by lowering the specific heat is that it will take lesser amount of heat for that water to boil. Shall you get? If you now look at which one is more, is it the a boiling point that it is increasing, or the specific capacity that it is reducing? You see that the increase in the boiling point with the salt is not very significant relative to the lower, like the specific capacity that is lowered, the specific heat of that water that is lowered. Okay, so food will cook quicker in salt water than in pure water. So if you like taking this challenge, tongue twister, foods cook quicker, foods cook quicker. Okay, steam from boiling water causes more damage on the skin than does boiling water, because this is because the steam, okay, it brings more heat easily by convection. Okay, steam has a greater heat energy per mass than water. Even though steam and water, okay, even though they are at the same temperature, 100 degrees Celsius, however, the steam has extra heat. Okay, it has latent heat of vaporization. So when it comes in contact with the body, it will release the heat its heat, okay, and the heat of vaporization. So they are like two heats that it is releasing to that body. So the damage that is going to cause to the skin is going to be more severe than that of ordinary boiling water. Okay, what will happen to the boiling point of pure water when it is heated in a place 30 meters below sea level? Now, below sea level, okay, the atmospheric pressure there will be even less. The boiling point of a liquid varies directly as atmospheric pressure. Okay, now the question is, if you ask us what is the boiling point of water, if you say 100 degrees Celsius, you may not exactly be correct. Okay, because it is a function of the atmospheric pressure. Now, under standard atmospheric pressure, that is 1 atmo, the boiling point of water is 100 degrees Celsius. However, if the atmospheric pressure changes, if it increases or decreases, then the volume of the boiling point of water would not remain at 100 degrees Celsius, it will change. Okay, if the atmospheric pressure increases, then the boiling point of the water would rise, okay, above 100 degrees Celsius. If it falls, then the boiling point of water is going to fall below 100 degrees Celsius. Now, in a place 30 meters below sea level, there is reduced atmospheric pressure, so the boiling point is going to be less than 100 degrees Celsius. Next, the rise or fall of liquid in a narrow tube is because of the surface tension of the liquid. Okay, it is because of the surface tension of the liquid. The mechanism of heat transfer from one point to another through the vibration of the molecules of the medium is heat transfer by conduction. Okay, heat transfer by conduction. So it occurs in solid objects. If it's a solid that is in contact with an heat source, for example, if you put a metallic spoon, if you put it inside fire, okay, or inside an heat source, basically put it in contact with an heat source, you notice that over time, okay, the other part of the spoon that is not even into the fire, or that's not touching that heat source, will also become, it will become hot. Okay, that is due to the transfer of heat through the vibration of the molecules of the medium. Solids, the molecules of a solid, the particles in the solid, they are densely packed together. Okay, so they don't move like those of liquid and gases. So instead, what they do is they vibrate. Now, during that vibration, heat is transferred from one particle to another until it gets to that end, okay, of the iron rod, or like the spoon, as an example that we are looking at, like the spoon. Okay, until it gets to that part of it that is not even into the heat source. Alright, finally, a wave traveling through stretched strings is known as, that is a mechanical wave. Okay, it is mechanical waves that require a material medium like air, for example, or the string, as is the case here. Okay, so it is a mechanical wave. All right, mechanical waves rather. Mechanical waves, they require a material medium for propagation. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Scholar. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.